Section 8.9 is graphs of linear inequalities. I can graph inequalities in two variables. A linear inequality in two variables, such as 2x minus 3y is less than 6, is the result of replacing the equal sign in a linear equation with less than or equal to, greater than or equal to. So we're going to do these very similarly to start off with, as how we did equations all chapter. So an ordered pair, xy, is a solution of a linear inequality if when we substitute it in for x and y, it produces a true statement. So that's not different than it was with equations. We're still going to substitute it in and ask ourselves, is this true? Does this make a true statement? So in example 1, we're going to tell whether the ordered pair is a solution. Remember, ordered pairs are x and then y. So I'm going to substitute those in for x and for y. So I keep my equation exactly as it is. 2 times x minus 3 times y is less than 6. And then I take those values of x and y and substitute them in. So 2 times 0 is just 0. Negative 3 times 1 is negative 3. And 0 minus 3 is negative 3. So negative 3 less than 6. Is that true? Is negative 3 less than 6? Yeah. So is it a solution? Yes. Same idea here with our second set of ordered pairs. Remember, we have x and y. I'm going to substitute my x in for x and my y in for y and see if it's true. So here I'm going to have 2 times x minus 3 times y is less than 6. And I'm going to take those values and plug them in. X is 4, y is negative 2. So 2 times 4 is 8. Remember, we take the sign with the number, so I have negative 3 times negative 2, which is positive 6. 8 plus 6 is 14. Is 14 less than 6? No. So is this a solution? No. Yes, a solution. Not a solution. The graph of a linear inequality in two variables is a set of points in a coordinate plane that represents all of the inequality solutions. And there's a picture on the bottom of page 436 that shows that. The boundary line divides the plane into two half planes. One of them has all of the shading, one of them has none of the shading. The shaded region is our solutions. A dashed boundary line is used to show points that are not solutions of the inequality, so like less thans or greater thans. A solid boundary line shows points that are solutions, and those come from less than or equal to or greater than or equal to. Just like when we had a number line and we'd put a circle, and if it was less than, we'd leave that circle open, and if it was greater than or equal to, we'd fill it in, and then we'd have to shade part of our number line. The same thing in two variables. We have to either fill in our line or leave it dotted, just like an open circle, and then we have to shade one part of our inequality. So to graph linear inequalities, first we're going to write an equation of the boundary line by putting an equal sign back in instead of an inequality. Then we're going to graph our line the same way we have been all chapter. The only difference is, if it was originally a less than or a greater than, we're going to use a dashed or a dotted line. If it's got this little equal to line, just like with our circles when we filled them in, we're going to fill in our line and make it a solid line. We're going to test a point on one of the half planes to figure out if it's a solution. If it is, we're going to shade on that side. If it's not, we're going to shade on the other side. So here in example 2, we're going to graph the inequality y is greater than or equal to 2x plus 4. I'm going to start off by replacing it with an equal sign, 2x plus 4, and I'm going to graph this line the same way that we have been all chapter. So since it's solved for y, I'm going to use mx plus b. I'm going to start at 4, and my slope is 2 over 1, so I'm going to go up 2 over 1. I can also go down 2, back 1. Now, we look at our original equation. because it's got that equal to line, it's a solid line. So when I go to connect these with a straight edge, I'm going to draw in my entire line. And I'm still going to put arrows. And just like with our inequalities in one variable, when we'd either keep our circle open or fill it in, and then we had to shade one side of our number line, we're going to do the same thing here. But sometimes it's a little bit harder to pick whether or not we shade the top or the bottom, or the left or the right. So we're going to use a test point here. We can use any point that's not already on our line. A good one to use, guys, is 0, 0. So as long as that's not on our line, our boundary line, we can check that point to see if it makes our equation, or our inequality, true. So we're going to say y is 0 greater than or equal to 2 times x, which is also 0, plus 4. And now we simplify. 2 times 0 is 0, plus 4 gives me 4. Is 0 greater than or equal to 4? No, 0 is less than 4. So since we can't shade in 0, 0, we have to shade in the other side. Remember, all of our solutions lie on the same half plane. So since I can't shade in 0, 0 because 0, 0 is not a solution, I have to shade in the other side. The other way we can think about this, guys, is we have a greater than. So we want our y's to be greater than the rest of our line. So we can pick any point on our line and make our y's go up. Any point on our line and make our y's greater. We go up from there. So we're going to shade above. Now, feel free to pause here and give this a try if you'd like. We're going to graph the inequality in a coordinate plane. So again, my first step is to replace my inequality symbol with an equals so that I can graph this the same way that we have been, at least to get my boundary line. So here it's not solved for y yet, so I can either solve it for y or I can use intercepts because it's in standard form. My x and y are on the same side, y is not by itself, so I'm going to use intercepts here. To find my x-intercept, I'm going to make y 0. So I'm going to have x plus 2 times 0, which is 0, equals 6. So my x-intercept is going to be at 6. So where x is 6, I put a point. To find my y-intercept, I make x 0. So I'm going to have 0 plus 2y equals 6. 0 plus 2y is just 2y. To get rid of my multiplication, I have to divide, and I get a y-intercept at 3. So where y is 3, I have a point. Now, we're going to draw in our line, but before we can do that, we are going to check to see if it's dotted or solid. So because this doesn't have the little equal to line there, it means it's a dotted or a dashed line. So when I connect my dots here, I'm going to do it with a dashed line. You should use a straight edge for this still to make sure that your line looks straight. I don't have a straight edge here, so mine's going to be pretty rough, but it's going to give you the general idea. There we go. And arrows to show it continues. Now, just like with our linear inequalities, or our inequalities in one variable, after we put our circle, we still had to shade one side. So here we need to figure out which side are we going to shade. We're going to pick a test point. And again, 0, 0 is a really good point to use as long as it's not on our line. So I'm going to plug in 0 for x and 0 for y and see if it makes a true statement. So here I get 0 plus 2 times 0 is greater than 6. Or 0 plus 0, which is 0, is greater than 6. Is 0 greater than 6? No. So I can't shade the side that has 0, 0. I have to shade my other side. Again, as long as our y is on the left, we can look at our inequality. We want our y value to be greater than. So here we can pick any point on our line and go up from there because y deals with our up and down. Since we want it to be greater, we want it to be bigger, and we can go up. And so all of this is our solution. Remember, it's got to all be on one side of our boundary line. In example 3 here, we're going to graph two lines. We're going to graph x less than 3 and y greater than or equal to -2 in a coordinate plane. So for x less than 3, remember, anytime we only have one variable, our line is going to be either straight left and right or straight up and down, straight horizontal or straight vertical. So here I have an x line, which means x is 3 here at my intercept. It's also 3 at the point 3, 2, and at 3, -5. So here, this is going to be a vertical line. If our only variable is an x, it's always going to be a vertical line. Now, I look at my inequality, and here I have a less than. I don't have an equal to line, so this is going to be a dotted line, just like it was before. So dotted line or dashed line. We still need to figure out which direction we're going to shade. So I can plug in a test point. Here I'm just worried about my x value. So if I pick x to be 0, for example, and check, is 0 less than 3? Yeah. So I can shade the side that has x to be 0 and everything else on the same side of my line. So my solution here for x less than 3 are all of these points. Now, y is greater than or equal to -2. Here, with y being -2, I put a point at y equals -2 on my axis. Again, one variable, so it's going to be a straight left and right or a straight up and down. Y is also -2 at the point 5, -2. At -4, -2. So here it's going to be a horizontal line. Since I have the little equal to part of my inequality, I can connect those with a straight line. Okay, it's going to be a solid line because I have a solid line as part of my inequality. We still need to figure out which direction to shade. So here I'm going to try y 0. 0 greater than or equal to -2. Is that true? Yeah, 0 is greater than -2. So since I can shade in 0 for y is 0 here, I shade on everything on the same side of my boundary line. So all of these points would make my inequality true. Nothing below, everything above. In number 2 here, we're going to graph the inequality in a coordinate plane. Feel free to pause and give it a try if you'd like. X is greater than or equal to -1. So we want all of the points where x is greater than or equal to -1. We don't care about our y's here, we just care about our x's. So x is -1 here. X is also -1 at the point -1, 3. And at -1, -5. And at -1, 6. So here we're going to have a vertical line. When we only have one variable, it's either straight vertical or straight horizontal. Because I have the equal to part of my line, or of my inequality, I'm going to have a solid line, and I can connect my dots. We need to figure out which way to shade here. I'm going to plug in a point like 0, for example. So if 0 is greater than or equal to -1, is that true? Yeah. So where x is 0 is part of my solutions, and I shade everything on that side. All of these points are solutions. None of the points on the other side are. Here I have y less than 3. So I go to where y is 3. It's also 3 at 4, 3, and 6, 3, and -4, 3. So it's going to be a horizontal line. Since I don't have the little equal to line there, it means it's going to be a dashed or a dotted line. I don't fill it in because my inequality isn't completely filled in. Now to pick where we shade, I plug in a point, like 0, for example. Is 0 less than 3? Yeah, so since 0 is less than 3, I shade in the side of my inequality that makes it true. All of these values, all of those points make it true. Nothing on the other side will. None of the other points on the side of my boundary line opposite of where I shaded will make it true. And I'm going to go ahead and pause here and continue in another video.